everyone, hope you all are doing good. I am Anjana from LearnoHub, the free learning platform where you can study math, science and SST absolutely free at learnohub.com. In today's class, we are going to discuss ICSE Class 10 Maths Chapter 20, Cylinder, Cone and Sphere. We'll be discussing about the cylinders. We'll study how to find the curved surface area, total surface area and volume of cylinder with examples and solve many questions from exercise 20A. Hope you all are ready. Let's begin. First, let us understand what a cylinder is. So, here you can see two examples, a battery. This shape is a cylinder, okay. Then a Coca-Cola bottle. Here this can has a cylindrical shape. Now a solid which has uniform circular cross section is called a cylinder. So this is the actual shape of a cylinder, okay. Now everywhere along the surface you have circular cross section and it is uniform circular cross section. For example, I'll show you. I have a few bangles here. So a bangle, we know a bangle is in circular shape, okay. I kept the first bangle, then the second bangle above it, third bangle above it, 4, 5, 6, 7, 8. 8 bangles I have kept. So, these are circles with uniform cross section, okay, uniform circular cross section. So, when I pile them, I get a cylinder. So, this shape is a cylinder. I have formed a cylinder, okay. When you have circles, similar circles which are piled up, you get a cylindrical shape. So, this is how a cylinder is formed. Clear? Now, when you consider this cylinder has a radius, okay, because we said when you take a bangle, so this bangle will be having a radius. Similarly, every bangle which I am using has a radius. So, this radius becomes the radius of the cylinder, okay, and it has a height. So, this is the required height, okay. Now, I am taking a rectangular sheet of paper. So, this rectangular sheet of paper will be having a length and breadth. This is the length and this is the breadth, okay, length and breadth. Now, when this rectangular sheet of paper, I am rolling it along the length, I am rolling it, I'll be getting something like this. So, this is a cylinder. Yes. Now, this is a cylinder. I have formed a cylinder with the rectangular sheet of paper. Now, just check this. Length of the paper becomes circumference of circle. Yes. We know circumference of circle is 2 pi r. This length becomes the circumference of circle 2 pi r. Okay. What about the breadth? When you roll the paper, the breadth, this part, the breadth, it becomes height of the cylinder. Yes. So, height is the breadth of the paper that we have used. Now, we have the perimeter or circumference of circle 2 pi r. Okay. What about this area? What about the area of this body of cylinder? Okay. Here we have a top. Similarly, we will be having a bottom. Consider this. This is in the shape of a cylinder. Okay. Here we have a bottom and here we have a top. Consider we have a top here. It is an open part. If it is closed, you will be having a top, bottom and top. This surface is called the curved surface of cylinder. This surface is a curved surface of cylinder. So, here in order to find the area of cylinder, you will be having a curved surface area which is along this, then the area of top and the area of bottom. To find the curved surface area of cylinder, curved surface area. To get the curved surface area, what we have to do is, we have to take the perimeter of the top or the perimeter of the circular cross section and multiply it with the height. Okay. Therefore, the curved surface area is equal to perimeter into height. So what is the perimeter here? 2 pi r is the perimeter. 2 pi r into height h. Okay. Therefore, the curved surface area of cylinder is 2 pi r h. Now consider here, if you can measure the diameter of this battery, you can find half the diameter is radius, and also with a scale you can measure the height. Then you can easily find what the curved surface area of this battery is. Come to this Coca-Cola can. Here again, if you can measure the diameter, you can find the radius, and also you can measure the height. In that case, you can easily get the curved surface area. If I want to paint this bottle, okay, I want to paint the curved surface of this bottle, then I can calculate the amount of area that is to be painted. Clear? Now, we have studied the curved surface area. Next is the total surface area. Total surface area. Okay. We got the curved surface area. Now, we have a bottom and a top. Okay. What is the area of bottom and top? Bottom and top are circles. How to find the area of a circle? We have area of circle is equal to pi r square. Area of circle is pi r square. We got the curved surface area. Total surface area will be curved surface area plus area of top plus area of bottom. Okay. Curved surface area, we have 2 pi r h plus area of top, that is pi r square. Next, area of bottom. Area of bottom is also pi r square, which is equal to 2 pi r h plus pi r square is 2 pi r square. 2 pi r square. Okay. Common. 2 pi is common. What else? R is common, which can be taken out. Then we have h plus r. Okay. Therefore, the total surface area is equal to 2 pi r into h plus r. This is how you can find the total surface area. Next, how to find the volume of a cylinder? What is volume? Volume of cylinder. Now, if I want to fill water in this, or if I want to fill something inside this, I need to know the capacity, how much this vessel can hold. I need to know. In that case, we will be calculating the volume. In order to get the volume of a cylinder, what we have to do is, we have to take the area of cross section into height. Okay. Here the area of cross section is pi r square and the height is h. Therefore, the required volume of cylinder can be calculated. V is equal to pi r square h. This is the formula to find the volume of cylinder. Got it? Any doubt? If you want to find how much Coca-Cola can this can hold, in that case, you just need to know the radius and height. By measuring the radius and height, putting into this formula, you can calculate the volume. Okay. For example, you have a big can which is cylindrical in shape. Okay. And you are asked to fill a few small cans using the water that is inside this big can. You need to find how many cans can be filled. For that, what you need to know? You need to calculate the volume of the big can, then volume of small can. So, to find the number of cans, you just need to divide the volume of the big can and the volume of small can. You will be getting the number of cans that can be filled. Clear? By solving questions, you will understand these in detail. So, for a cylinder, curved surface area is 2 pi RH, where R is the radius and H is the height. Total surface area is 2 pi R into R plus H, and the volume is equal to pi R square H. So, we know to calculate curved surface area, total surface area and volume of a cylinder. Clear? Next is hollow cylinder. A cylinder which is empty from inside and has some difference between internal and external radii. I'll show you here. This is how a hollow cylinder looks like. Here we'll be having an internal radius. This is internal radius R and this is external radius capital R. This is the height of cylinder. Now, here I have an example. This is a hollow cylinder. You can find an inner circle and an outer circle. This inner circle will be having a radius which is different from the radius of outer circle. Okay. So, if you need to find the curved surface area, total surface area and volume, we have different formulas. Let's see. Again, just look at this figure. This is an example of hollow cylinder. In case of hollow cylinder, there will be a thickness. This distance is the thickness. Okay. Here, capital R minus small r will give us the thickness. Thickness is equal to capital R minus small r, which is the thickness of the material. Okay. What about area of cross section then? Area of cross section will be equal to area of the bigger circle minus area of smaller circle. That is pi capital R square minus pi small r square, which is equal to pi into capital R square minus small r square. Okay. Next, we'll find the curved surface area. When it comes to curved surface area, we have two types of curved surface area here. One is for the internal part and the other for external part. Internal curved surface area and external curved surface area. To find the internal curved surface area, we will use the internal radius, and to find external curved surface area, we will be using the external radius. How to find the curved surface area? Curved surface area is perimeter into height. For the internal circle, the perimeter will be 2 pi small r into height, which is h. Okay, which is the internal curved surface area. Now, when it comes to external curved surface area, it will be equal to perimeter of the external circle, which is 2 pi capital R into height h. Okay, 2 pi capital R into h. Next is the total surface area. How to find total surface area here? How many surfaces we have? When you consider the normal cylinder, it was the area of top, area of bottom plus areas, the curved surface area. When it comes to the hollow cylinder, you will be having the outer curved surface area, inner curved surface area. Then this part, yes, this area of cross section. Clear? That is internal curved surface area plus external curved surface area plus area of cross section. Internal curved surface area is 2 pi small r h. External curved surface area is 2 pi capital R h plus area of cross section. Area of cross section is pi r square minus r square. Okay. So, here we have the area of cross section of the top and the bottom. Therefore, 2 pi capital R square minus small r square. Okay. So, this is how you can find the total surface area of hollow cylinder. Now, the volume. Volume, that is the amount of metal that is present here. Okay. In order to find, we need the volume. volume is equal to, again, the area of cross section, pi r square minus r square into height, h. So this is how you can find the volume of cylinder. Clear? Internal curved surface area is 2 pi RH. External curved surface area is 2 pi capital RH. Total surface area includes internal curved surface area, external curved surface area and 2 into area of cross section. 2 pi capital RH plus 2 pi small rh plus 2 pi into capital R square minus small r square. Then the volume will be external volume minus internal volume, which is pi capital R square h minus pi small r square h, and we get pi into r square minus r square into h. So this is a case of hollow cylinder. Okay, let us take an example. The area of the curved surface of a cylinder is 4400 centimeter square and the circumference of its base is 110 centimeter. Find the first one, height of the cylinder, and second, volume of the cylinder. Okay. We have formulas to find curved surface area, total surface area and volume of cylinder. We have studied the formulas. Now here what is given? Given that curved surface area is equal to 4400 centimeter square. Okay. What is curved surface area? How to find curved surface area? What is the formula? 2 pi RH. So 2 pi RH is equal to 4400. Okay. Let us keep this as first equation. Now what else is given? Circumference of base is given. Circumference of base. Base of a cylinder is circular in shape, which means we know the circumference of circle. How to find circumference of circle? Circumference of base is given here, which is equal to 110 centimeters. Okay. To find the circumference of circle, we have a formula 2 pi r. 2 pi r is equal to 110. We take this as equation 2. So in equation 1, we have 2 pi r. Okay. So substituting second equation in first equation. Substituting the second equation first, in place of 2 pi r, we are going to put 110. 110 into h is equal to 4400. Then what is h? H will be equal to 4400 divided by 110. 0 gets cancelled. 11 into 4 is 44. Again we have a 0, which means 40 centimeter is the required height of cylinder. Second part, we need to find volume of cylinder. Volume. How to find volume of cylinder? What is the formula? V is equal to pi r square h. Here we need the value of r. How to find r? H value we know. H is 40 centimeter. Okay. We have 2 pi r is equal to 110. From which we can find the value of r. Circumference of circle is 110. Then r is equal to 110 divided by 2 pi. Okay. Radius is 110 divided by 2 pi. Now volume will be equal to pi r square. R square is 110 divided by 2 pi whole square into h, which is 40. Therefore, V is equal to pi r square h. Pi r square is 110 divided by 2 pi whole square into h we have determined, which is 40. Okay. Equal to pi into 110 into 110 into 40. What about denominator? Denominator we have 2 pi. 2 pi square. 2 pi into 2 pi. Pi gets cancelled. Here we have 2 and this 2 can be cancelled. 2 into 2, 4. 4 into 10 is 40. This becomes 10. Then this pi can be written as 110 into 110 into 7 divided by 22. Pi is 22 by 7, taking reciprocal 7 by 22. Okay, 22. 2 into 11 is 22. 11 into 10 is 110. Okay, then here this 2 and 110 can be cancelled. We get 55. Okay, 55 into 7 into 10. 55 into 7 will be getting 3850. Again we have a 0. So the final answer is 38,500. What is the unit? Volume of cylinder. Here height and radius are in centimeter. Therefore the volume should be in centimeter cube. Okay. So the final answer is 38,500 centimeter cube. Clear? Second example, the volume of a solid cylinder is 96,228 centimeter cube and the ratio of its radius to its height is 9:14. Find the total surface area of the cylinder. We need to find the total surface area of cylinder. Okay. Here, given that the ratio of radius and height, we need to find the radius and height then. We don't know what the exact value of radius and heights are. Okay. Given volume V is equal to 96,228 centimeter cube. Okay. Let radius is equal to, the ratio is 9:14. We'll take radius as 9x centimeter. Then what is the height? Height will be equal to 14x centimeter. Okay. We need to find the total surface area. What is the volume of a cylinder? Volume V is equal to pi r square h. Yes. So, pi r square h value we have. That is 96,228. Pi r square h is equal to 96,228. Now we have r 9x and h 14x. Put the values. Pi into 9x whole square into 14, x is equal to 96,228. Okay, x square into x is x cube. X cube will be equal to 96,228 divided by, bring all other terms to the opposite side. This pi is 22 divided by 7. Taking the reciprocal, we get 7 by 22. Okay, 7 by 22. Then we have 9 square, 9 into 9 and 14 into 14. Okay, when you do the calculations, you will be getting x cube equal to 27. What is the cube root of 27? X will be cube root of 27. And the cube root of 27, we know 3 cube is 27. Therefore, cube root of 27 will be 3. 3 centimeter. Okay. Then what is the radius r? R will be equal to 9 into 3. 9x, which is 9 into 3, and that is 27 centimeter. What about height h? H will be equal to 14x. 14 into 3, that is 42 centimeter. We got the radius and the height. Now we can easily find what the total surface area is. Total surface area. What is the formula to find total surface area? Equal to 2 pi r into r plus h. That is the curved surface area. Then you will be adding base and top. Area of the base and top. Base and top are circles. So, pi r square will be added to this. Now, put the values. 2 into 22 divided by 7 into r is 27 into r plus h. 27 plus 42. That is 2 into 22 divided by 7 into 27 into 27 plus 42. What do we get? 69. Okay. When you do the calculation, when you calculate this, the final answer will be 11,710.3. What about the unit? This is total surface area. Therefore, the unit is centimeter square. Okay. So, this is your final answer. Clear? Let us solve more problems from exercise 20A. Problem 1, question 1 of exercise 20A. The height of a circular cylinder is 20 centimeter and the radius of its base is 7 centimeter. Find first the volume and then the total surface area. Okay. Given height h is equal to 20 centimeter, then radius of base is given r is equal to 7 centimeter. First we need to find volume. How to find volume? Volume V of a cylinder is equal to pi r square into h. If you have the formula ready with you, just by substituting the values, you can easily find the answer. That is 22 divided by 7 into 7 square. 7 into 7 into height 20. 7 and 7 get cancelled. Then you have 22 into 20, 440 into 7. When you do this calculation, 440 into 7, you get 3080 centimeter cube. Okay. Never forget to put the unit here. For volume, the unit is centimeter cube. Next, we need to find the total surface area. How to find total surface area? Total surface area. What is the formula to find total surface area? 2 pi r into r plus h. How do we get this? So here, if you have the cylinder, this is the curved surface. So the area of curved surface is 2 pi r h. Then you have a base and top. Base and top are circular in shape. Pi r square for base and pi r square for top. 2 pi r h plus 2 pi r square. 2 pi r taken out, then r plus h. Okay. You should have an idea how we are getting this. Now put the values. 2 into 22 divided by 7 into radius. Radius is 7. R plus h. R is 7 and height is 20. We get 2 into 22 into 7. 7 gets cancelled. 7 plus 20 is 27. When you calculate, your answer will be 1188 centimeter square. Here the unit is centimeter square because this is an area. For area, unit is centimeter square. If you have radius and height in meters, then it will be meter square. Now when it comes to volume, the unit is centimeter cube. If the radius and height are in meters, then it will be meter cube. Okay. Second problem. Question 2 of exercise 20A. The inner radius of a pipe is 2.1 centimeter. How much water can 12 meter of this pipe hold? Here, given that the inner radius of pipe, we have a pipe. Okay. The inner radius of the pipe is given, which is 2.1 centimeter. How much water can 12 meter of this pipe hold? What is this 12 meter? 12 meter will be the height of pipe. Okay. Given radius r is equal to 2.1 centimeter. Okay. Then we have height. Height h is equal to 12 meter. Here radius is in centimeter and height is in meters. Either you have to convert the radius into meters or height to centimeter. So it is easy to convert height to centimeter. We have 1 meter is equal to 100 centimeter. Therefore 12 meter will be 1200 centimeter. Okay, how much water can it hold? How much water? In that case, we are going to find the volume, not the surface areas, because amount of water, the quantity of water we need to find, which means it is the volume. How to find volume? Volume V is equal to pi r square h. Okay, pi r square h. Now put the values. Pi 22 divided by 7 into 2.1 into 2.1. Height is 1200. Okay, when you do this calculation, you will be getting 16,632 centimeter cube. So this is the amount of water that the pipe, this pipe with 12 meter of length can hold. Okay, very simple question, right? Problem number 3, question 4 of exercise 20A. How much cubic meters of earth must be dug out to make a well 28 meter deep and 2.8 meter in diameter? Also find the cost of plastering its inner surface at rupees 4 rupees 50 paise per square meter. Okay, here from the earth surface, we are going to dig a well which is cylindrical in shape. The diameter is given. So this is the diameter. Let us consider this to be our well from the earth surface. Diameter is 2.8 meter. Okay, 2.8 meter. And the depth. Depth means this is the required depth. Depth is given, which is 28 meter. So we need to find the amount of earth that is dug out, which means that it is a volume to be determined. Given diameter D is equal to 2.8 meter. We don't need the diameter, we need the radius. How to find radius from diameter? R is equal to diameter divided by 2. 2.8 by 2, which is 1.4 meter. Okay, the radius is 1.4 meter. Next, it is given the depth. Depth h is equal to 28 meter. Now we can find the volume. Volume V is pi r square h. Put the values. Pi 22 divided by 7. R square. Radius is 1.4 into 1.4 and height is 28. Okay. Equal to 22 by 7. 1.4 can be written as 14 divided by 10. We are converting the decimal to fraction form. Again 14 by 10 into 28. So when you calculate this, so 7 and 14 can be cancelled. You get 2 here. So the answer will be 17248 divided by 10 into 10. 100, which is equal to 172.48, and the unit here meter cube. 172.48 meter cube. Okay. Next, we need to find the cost of plastering its inner surface at rupees 4.50 per square meter. Inner surface means the curved surface. If the curved surface is to be plastered, we need to find the cost. Okay. For 1 meter square, the cost is given. First, we need to find the curved surface area. CSA is equal to 2 pi r h. Put the values. 2 into 22 divided by 7 into radius is 14 by 10 and the height is 28 meter. Again cancelling, we get 2 here. So 2 into 22 into 2 into 28 divided by 10. So you will be getting 2464 divided by 10. Okay, the final answer will be 246.4 meter square. The curved surface area will be 246.4 meters square. Okay, now we need to find the total cost for plastering. So, cost for 1 meter square is given, that is equal to rupees 4.50. Therefore, cost for 246.4 meter square will be equal to 246.4 into 4.50. Okay, when you calculate this, you will be getting rupees 'So this will be your answer, 1108.8 rupees. Clear? Problem number 4, question 7 of exercise 20A. A metal has a bore inner diameter of 5 cm. The pipe is 5 mm thick all round. Find the weight in kilogram of 2 meters of the pipe if 1 cm cube of the metal weighs 7.7 gram. Okay. Here we have the pipe. So this pipe has inner diameter which is given. Then the thickness is given. Thickness is 5 millimeters. You will also have an outer diameter or outer radius which can be determined. To get the volume, we have to subtract internal volume from the external volume. So separately we need external and internal volume. Once you subtract, you will be getting the volume of pipe. Given that 1 centimeter cube of the metal, the weight is 7.7 gram. So once you find the total volume, we can from this find the weight of the metal that is required. What are the given quantities? Given inner diameter. Inner diameter is equal to 5 centimeter. If inner diameter is 5 centimeter, what is the inner radius? Inner radius R is equal to 5 divided by 2 centimeter or 2.5 centimeter. We know that radius is half of diameter. What about the outer radius? Outer radius or the external radius? Capital R. We'll take this as capital R is equal to. Here, this is the inner radius. To get the outer radius, which is this total distance, we are adding the thickness of the pipe to it. Okay. It will be inner radius plus thickness. What is the inner radius? Inner radius is 2.5 centimeter plus thickness is given 5 millimeter. We have 1 centimeter is 10 millimeter, which means 1 millimeter will be equal to 1 by 10 centimeter. Here we have 5 millimeter. 5 millimeter will be 5 by 10 centimeter, that is equal to 5 divided by 10, 0.5 centimeter. Okay. So 0.5 centimeter should be added. 2.5 centimeter plus 0.5 centimeter, you get 3 centimeter. Okay. So 3 centimeter is the outer radius. Now we can separately find the volume. So to get the volume of pipe, we'll be having external volume minus internal volume. Okay. External volume will be pi capital R square into H minus internal volume will be pi small r square into H, that is equal to pi H into capital R square minus small r square. Here what is the height? Height is also given in the question, that is 2 meters of the pipe. Height H is equal to 2 meters. So converting into centimeters, you get 2 100 centimeters. Okay. Now, to find the volume, V is equal to 22 divided by 7 and height is 200 into capital R square. Capital R square is 3 square, small r square 2.5 square. Okay, this is of the form a square minus b square. To make the calculation easier, we can put a plus b into a minus b form. 22 divided by 7 into 200 into 3 plus 2.5, 3 minus 2.5. Okay, a square minus b square equal to a plus b into a minus b. That is 22 by 7 into 200 into 3 plus 2.5, 5.5 into 3 minus 2.5 is 0.5. When you calculate this, you will be getting 8.6 centimeter cube. Okay, 1728.6 centimeter cube is the volume. Clear? So, we got the total volume. Given that for 1 centimeter cube, the weight is 7.7 gram. Weight for 1 centimeter cube, it is 7.7 gram, which will be equal to 7.7 divided by 1000 kilogram. We have 1 kilogram is equal to 1000 grams. Okay. Then 1 gram will be 1 by 1000 kilograms. Here we have 7.7 grams. 7.7 grams will be equal to 7.7 by 1000 kilograms. Now, to find the weight for 1728.6 centimeter cube is equal to, just do the multiplication, 1728.6 into 7.7 divided by 1000. That will be equal to, you will be getting 13.31 kilograms. Okay, so this is the required weight, 13.31 kilograms of metal. Understood? Problem number 5, question 11 of exercise 20A. The height and the radius of the base of a cylinder are in the ratio 3:1. If its volume is 1029 pi centimeter cube, find its total surface area. So, here pi is given as it is, which will make the calculation easier. Now, we don't know the exact value of what radius is, what height is. We need to find total surface area. What is given? The ratio of height and the radius is given. So, we will be taking, let height h is equal to, the ratio is 3:1. So, height can be taken as 3x. Okay. Then, what about radius? Radius r will be equal to 1x. What is given? Volume is given. Volume V is equal to 1029 pi centimeter cube. How to find volume? Volume is pi r square h. Pi r square h is 1029 pi. Okay. We have r is equal to 1x and h is equal to 3x. Substitute here. Pi into x square, h is 3x, is equal to 1029 pi. Okay, we need to find the value of x. X square into x is x cube. X cube is equal to 1029 pi divided by, bringing this pi and 3 to the right hand side, it becomes division, we will be having 3 pi. Pi and pi can be cancelled. 1029 divided by 3, we get 343. Okay, x cube is equal to 343. Then what is the value of x? X will be cube root of 343. 7 into 7 into 7 is 343. Therefore, the cube root of 343 is 7. 7 cube is 343 and the cube root of 343 is 7. X is equal to 7. Then what is the height? Height h is equal to 3 into x, which is 3 into 7, 21 centimeter. What about radius? Radius r is equal to x value which is 7 centimeters. Now we need to find the total surface area. Okay, total surface area. How to find total surface area? 2 pi r into r plus h. Put the values. 2 into 22 by 7 into r is equal to 7 into r plus h. 21 plus 7, that is equal to 2 into 22 by 7 into 7 into 21 plus 7, that is 28. 7 can be cancelled. Then we have 44 into 28. Multiplying 44 and 28. 28 into 44. 8 4s are 32. 4 2s are 8. 8 plus 3, 11. Again 1 1 2. 2, 3, 2, 1. So the final answer is 1232 and the unit for surface area centimeter square. 1232 centimeter square. Here, problem number 6, question 13 of exercise 20A. The radius of a solid right circular cylinder decreases by 20% and its height increases by 10%. Find the percentage change in its first one, volume, and the second, curved surface area. Okay, here we have a cylinder. Let us take the radius as r and height h. Now what happens? The radius of solid right circular cylinder decreases by 20%. By 20%, the radius is decreasing. Okay. So we'll get a new cylinder such that the radius has decreased by 20% and at the same time height increases by 10%. By 10% height is increasing. We'll take the new radius as r dash and the new height as h dash. For our convenience, let us take the radius as some 100 centimeter and height also 100 centimeter. Let radius of original cylinder r is equal to 100 centimeter. Next, height of original cylinder h is equal to 100 centimeter. Then what is the volume? Volume of original cylinder V will be equal to pi r square h. That is pi into 100 square into 100, which is equal to 000000 pi. 10 lakh pi centimeter cube. So this is the volume of original cylinder. Now what is happening? The radius is decreasing by 20% and height is increasing by 10%. Okay. First we'll find 20% of 100 centimeter. What is 20% of 100 centimeter? 20 divided by 100 into 100, which is equal to, cancelling, 20 centimeter we get. 20% of 100 centimeter is 20 centimeter. The radius is decreasing by 20 centimeter. So the new radius R dash is equal to original radius 100 centimeter minus 20% decrease, that is minus 20 centimeter. 100 centimeter minus 20 centimeter, we get 80 centimeter. Next, we need to find the 10% of 100 centimeter will be equal to 10 by 100 into 100, cancelling we get 10 centimeter. Okay, 10% of 100 centimeter is 10 centimeter. Therefore, the new height h dash is equal to original height, which is 100 centimeter plus amount of increase 10 centimeter, 110 centimeters. Okay, then what is the new volume? New volume V dash is equal to pi R dash square H dash pi R dash square 80 square and H dash is 110. We'll be getting 704,000 pi centimeter cube. So this is the new volume. We have original volume and the new volume. We need to find the percentage change in its volume. Therefore, the change in volume is equal to original volume minus new volume. What is the original volume? Original volume we have 10 lakh pi centimeter cube and the new volume is 7 lakh 4,000 pi centimeter cube. On subtracting, we get 2 lakh 96,000 pi centimeter cube. So this is the change in volume. Once you get the change in volume, you can find the percentage change. Percentage change will be equal to change in volume divided by original volume into 100%. Okay. Change in volume is 2,96,000 pi. Original volume is 10 lakh pi into 100. Zeros. Here we have 3 zeros. 3 zeros cancelled. Pi and pi can be cancelled. Then you will be having 296 divided by 10, which is 29.6%. So this is the percentage change in volume. Clear? When the radius decreases by 20% and height increases by 10%. Okay. Next, we need to find the percentage change in the curved surface area. Second part. We know the radius and height of the original cylinder and the radius and height of new cylinder formed. So, in order to calculate the curved surface area of original cylinder, what is the formula? That is equal to 2 pi r into h. Put the values. 2 pi r is 100, h is also 100. That is equal to 20,000 pi centimeter square. Centimeter square is the unit for area. Next, the curved surface area of new cylinder will be equal to 2 pi r dash h dash. R dash is 80 and h dash is 110 equal to 2 pi into 80 into 110, which is 176,000 pi centimeter square. We got the curved surface area of original cylinder and the curved surface area of new cylinder. Change in CSA. Change in curved surface area is equal to curved surface area of original minus curved surface area of new cylinder. Now put the values. Curved surface area of original cylinder is equal to 20,000 pi minus curved surface area of new cylinder 17,600 pi. On subtracting this, we get 2,400 pi. So 2,400 pi centimeter square is the change in curved surface area. Therefore, the percentage change in curved surface area is equal to change in curved surface area divided by original curved surface area into 100%. What is change in CSA? Change in CSA we have determined equal to 2,400 pi divided by original curved surface area is 20,000 pi into 100%. Okay, pi gets cancelled. 2 zeros from here, 2 zeros from here. 24 divided by 2, which is equal to 12%. Therefore, the percentage change in curved surface area is 12%. Clear? 12% change happens to curved surface area when the radius of the right circular cylinder decreases by 20% and height increases by 10%. Okay. Problem number 7, question 16 of exercise 20A. Find the volume of the largest cylinder formed when a rectangular piece of paper 44 cm by 33 cm is rolled along its shorter side, second longer side. We know that using a rectangular sheet of paper, we can form a cylinder. So here I have a rectangular sheet of paper. When I roll it like this is a cylinder. Okay, we have a cylinder. Or if I roll it this way, when I roll it this way, again I am getting a cylinder. Okay. In both these cases, we will be getting cylinder. So first, let us consider we have the longer side 44 cm and the shorter side 33 cm. This is 33 cm and 44 cm. This part is 44 cm. Let us assume. Now, first we are rolling along its shorter side. Which is the shorter side? This is the shorter side. Okay. So, we are rolling along shorter side, which means this way. This is how you will be rolling. So, this is the required cylinder. Now, we have the rectangular sheet of paper, longer side 44 cm and the shorter one 33 cm. So, rolling along the shorter side, we will be getting a cylinder like this. Okay. If you roll in this way, when you roll this way, this 44 cm will become the height of cylinder. What about 33 cm? Here we are rolling it. Okay. When we roll this way, this 33 cm is the circumference of circle. Yes, it is the circumference of this circle. Okay. We need to find the volume. So, for the first case, we have height h is equal to 44 centimeter. Okay. We need to find the radius. Radius we don't know. To get the volume, we need the radius. What we know is circumference. Circumference is equal to 33 centimeter. If circumference is 33 centimeter, we can write 2 pi r is equal to 33 and then r is equal to 33 divided by 2 pi, that is 33 divided by 2 into 22 by 7, which is equal to 33 divided by 2 into 22 into 7. We are taking the reciprocal and multiply. 22 is 2 into 11. 33 is 3 into 11. Okay. 3 into 7, 21 divided by 2 into 2, 4. So, you will be getting 21 divided by 4, which is equal to 5.25 centimeter. So, the required radius is 5.25 centimeter, or you can keep the fraction like this, that is 21 divided by 4. Now, we can find the volume. Volume V is equal to pi r square h. Put the values. Pi 22 divided by 7, radius 21 by 4. 21 by 4, again 21 divided by 4, and height is this 44. Okay. 7, 21 can be cancelled. We'll be getting 3 here. 4, 44 can be cancelled. You get 11. Again this 4 and 22 can be cancelled. You will be getting 11 and 2. Okay. 11 into 3 into 21 again into 11 divided by 2. So, you will be getting the answer. So, your final answer will be 3811.5 centimeter cube. Okay. 3811.5 centimeter cube is your final answer. This is the required volume of the cylinder formed when it is rolled along the shorter side. Okay. Next, when it is rolled along the longer side. So, this is the longer side. Here we have the longer side, 44 centimeter. So, rolling along longer side, this is your required cylinder. Okay. The cylinder will be in this way. Here, (44), (33), we are rolling along the longer side. The cylinder will be in this way. Okay. Now, this 44 becomes circumference. Circumference is equal to 44 centimeter. Okay. That is 2 pi r is 44 centimeter. What about height? This 33 becomes the height. Height of cylinder is h is equal to 33 centimeter. Okay. Now, we can find the radius from this. What is the radius? 2 pi r is equal to 44. 2 into 22 by 7 into r is equal to 44. Then r is equal to 44 into 7 divided by 2 into 22. 2 into 22 is 44. So, this and this can be cancelled. We get 7 centimeters. Okay, 7 centimeters. Now, the volume. Volume V is equal to pi r square h. Substitute the value pi. 22 divided by 7 and the radius is 7 centimeter. 7 into 7, height. In this case, the height is 33. 33. That is equal to 7 and 7 gets cancelled. 22 into 7 into 33. Your answer will be 5082 centimeter cube. Okay. In this case, when the cylinder is in this way, you will be getting 5082 centimeter cube as the volume. So, what did you understand? When the same sheet of paper is rolled in the form of cylinder with the shorter side and along the longer side, the volume will be different. Okay. Problem number 8, question 19 of exercise 20A. The sum of the inner and outer curved surfaces of a hollow metallic cylinder is 1056 centimeter square and the volume of material in it is 1056 centimeter cube. Find its internal and external radii given that the height of cylinder is 21 centimeter. Okay. The sum of inner and outer curved surface is given. Okay. So here let us take, let inner radii be small r and outer radii be capital R. Okay. Inner curved surface area plus outer curved surface area is given, that is equal to 1056 centimeter square. How to find inner CSA? Inner CSA will be 2 pi inner radius into height. Height of cylinder is h. Okay. Outer curved surface area will be 2 pi capital R into h. And that is equal to 1056 centimeter square. 2 pi h is common. Taking out, will be having capital R plus small r. That is equal to 1056. Okay. From which we can find what capital R plus small r is. 2 into 22 divided by 7 into height. Height is given, which is 21 centimeter, into capital R plus small r is equal to 1056. Then what is r plus r? R plus r is equal to 1056. Taking all these terms to the opposite side. 22 by 7 reciprocal, 7 divided by 22 into, then we have 2 and 21. 1 by 2, 1 by 21. Okay. That is 1056 into 7 divided by 22 into 2 into 21. 7, 21 when cancelled we get 3 here. Then 3 and 1056 can be cancelled. Here we will be getting 3, 5, 2. Okay. 2 and 352 can be cancelled. It will be equal to 176. 22 is 11 into 2. Here we will be getting 16. Then 16 divided by 2 is equal to 8. Therefore, we got capital R plus small r is equal to 8. Okay, keep it as equation 1. Next, what is given? It is given that the volume of the material in it is 1056 centimeter cube. What is the volume of hollow cylinder? We have volume V is equal to pi into capital R square minus small r square into h. This is the volume of hollow cylinder. Yes. Value is given pi capital R square minus r square into h is equal to again 1056. Now substitute the values. 22 divided by 7 into r square minus r square into h. h is equal to 21 is equal to 1056. 7, 21 can be cancelled. We get 3 here. Then what is r square minus r square? That is 1056 divided by 22 into 3. Again cancelling. 3 and 1056 can be cancelled. We get 352. Here 22. 22 is 11 into 2. 352 is 32 into 11. Again cancelling. We get 16. We have capital R square minus small r square is equal to 16. A square minus B square form. It can be written as R plus R into R minus R equal to 16. What is r plus r? The sum of internal and external radius is equal to 8. 8 into r minus r is equal to 16, which means r minus r is equal to 16 by 8 and that is equal to 2. R minus r is 2. R minus r equal to 2. We take it as equation 2. So this is my first equation and this is my second equation. We need to find the inner and outer radii, internal and external radii. Here adding 1 and 2, we get r plus r, capital 2r, then small r minus r, it becomes 0. Right hand side 8 plus 2, 10, which implies capital R is equal to 10 divided by 2 and that is 5 centimeter. If capital R is 5 centimeter, 5 centimeter plus small r is equal to 8. I am substituting capital R value in the first equation. You can also substitute in the second equation, which implies small r is equal to 8 minus 5 and that is 3 centimeter. Okay, 3 centimeters. We got the inner radii 3 centimeter and the external radii 5 centimeter. Okay. Understood this problem? Okay, fine. Here we have the last problem for today. Problem 9, question 27 of exercise 20A. Two right circular solid cylinders have radii in the ratio 3:5 and heights in the ratio 2:3. Find the ratio between their curved surface area and volumes. Here, no values are given. We don't know the radius, we don't know the height. Only the ratio of their radii and the ratio of their heights are given. Okay. Let radius and height of first cylinder be R1 and H1. Okay, we are taking the radius of first cylinder as R1 and that of second cylinder as R2. So height we have taken as H1. Now radius and height of second cylinder be R2 and H2. So what is given? It is given that the radii ratio of the radii is 3:5. So we can write R1 divided by R2. R1 is the radius of first cylinder and R2 is the radius of second cylinder. R1 by R2 is equal to 3 divided by 5. Okay. Then heights are in the ratio 2:3. Okay. If heights are in the ratio 2:3, then height of first cylinder H1 divided by the height of second cylinder H2 is equal to 2 divided by 3. So we have R1 by R2 3 by 5 and H1 by H2 2 by 3. Okay. We need to find the ratio between curved surface area. How to find curved surface area? CSA. Curved surface area is equal to 2 pi RH. This is a curved surface area. Okay. Curved surface area of first cylinder will be 2 pi R1 H1 by curved surface area of the second cylinder. Second cylinder, it will be 2 pi R2 H2. So this is the ratio of curved surface area of first cylinder to the curved surface area of second cylinder. Okay. That is equal to 2 pi can be cancelled. Then we have R1 by R2 into H1 by H2, which is equal to R1 by R2 we have 3 by 5. 3 by 5 into H1 by H2 is 2 divided by 3. 2 by 3. Okay. 3 and 3 gets cancelled. 2 by 5. So ratio of curved surface areas is equal to 2:5. Okay. Now the second part, we need to find the ratio of their volumes. How to find volume? Volume of cylinder V is equal to pi r square h. So here the required ratio will be pi r1 square h1 divided by pi r2 square h2. That is equal to pi and pi gets cancelled. R1 divided by R2 whole square into H1 by H2. R1 by R2 whole square, 3 by 5 whole square. H1 by H2 is 2 divided by 3. 2 by 3. That is equal to 3 into 3 into 2 divided by 5 into 5 into 3. Okay, 3 and 3 can be cancelled. So, in the numerator, 3 into 2, we have 6 and 5 into 5, 25. So, the required ratio of volumes is 6:25. Okay, ratio of CSA is 2:5 and the ratio of volumes is equal to 6:25. Clear? That's all for today. In today's class, we have determined how to find the curved surface area, total surface area and volume of a normal cylinder and hollow cylinder. We have solved many problems related to this. There are a few more problems which are left in your exercise 20A which you can solve on your own. I'll be back in the next session. Until then, stay tuned to LearnoHub. LearnoHub free hai, पर best hai. Thank you.